Welcome to another edition of Smalltalk for you. This morning I wanted to continue with processes in Smalltalk, and while we're using VA Smalltalk, the same thing is going to apply to Faro, VisualWorks, and most Smalltalks. Matter of fact, I'll show you one of the simpler examples in Faro to demonstrate that. What I'm going to talk about is how the Smalltalk processing model is a cooperative model, not a preemptive model. And to show that, let's go ahead and do something like this. I'm going to create a process just like the one I created last time I did this. Condition is less than 10, add the results to a collection, and then just keep adding 1 to it until I get to 10, so I should get 1 through 10 in this collection. And then another process running at the same priority level. Notice I'm forking both, and this one's going to add numbers from 20 to 30. And if this were a preemptive system, you might see the numbers intermixed, 1, 20, 2, 21, and so on. Let's see what actually happens. I'll create the collection, I'll run both processes. Now that doesn't take too long because we're just doing something really quick, and what we'll do is we'll inspect the collection and look at what happens here. I have numbers 1 through 9, and then I started on 20. And why is that? Well, it's because both of these processes are running at the same priority. So the first one holds the processor until it's done, because it never hits an I/O wait state, never yields, it never runs into any situation where it has to be suspended. If you want to simulate hitting an I/O state, what you can do is you can send yield to a process. So here I have the same process as above. The only difference is I'm going ahead and after each addition, I'm doing a processor yield in both of these two processes. Let's go ahead and create another collection, fork both of these guys, execute it, and now we'll go ahead and take a look at collection 2. And you see here they're interleaved because as each process yields, it gives the other one a chance to run. Now to show you that this is the same in other Smalltalks, let's pull Faro into this mix, and we'll run the simpler example here. This is just where we should see the numbers 1 through 9 and then 20 through 29. Let's go ahead and execute this. And then we'll take a look at this collection. And you see that I'm getting the same results I got over in VA. That's because the Smalltalk processing model is pretty much the same across all the Smalltalks. Now, let's go ahead and take a look at how you can get something that operates a little differently. You want to have one process that's going to have some higher priority than another one. You want it to run first, get a higher shot at the processor. So what I'm going to do is create another process just like the ones above. And what I'm going to do is I'm going to give this one a delay in the middle here. And then I'm going to run the second one with user interrupt priority. So this one's forking, so it's going to run at the standard priority. This one's going to run at a higher priority. And the reason I'm putting the delay in here is so that after the first one runs, you can kind of see what's happening, so that you can see that this one's continuing to run instead of going very fast. So this one will run a little longer, and you'll see that this one kind of hijacks the thing and takes over. So let's go ahead and execute both of these. And we'll do an execute. Now let's take a look at collection 3. And while the first process is running, you see that we've got 1, so it ran. Then the second one took over. And then here at the end, you see that when I inspected this, the first one was still running. So the second one grabbed control, ran to completion before the first one got a shot at running again because it was at a lower priority. And that's kind of the same thing as this yield between two processes of the same priority. Any process at a higher priority, when the current process goes into a wait state, will grab control. So when there is a chance for the processor to hand control over, it'll hand it to a higher priority process. Now finally, what if you need to kill a process? Now I mentioned in the last screencast that what you can do is you can hold a reference to a process the way I've been doing here. So proc 7 is this. Notice the condition here. Instead of a condition that's going to terminate, this one never will. True while true, delay for seconds, and toss something to the transcript. So let's go ahead and execute this. And unless I terminate this or kill the image, this guy's going to run forever. So if I go up here, you can see executing, and if I wait long enough, executing again. So it's just running. And if I take a look at the process, let's go ahead and inspect this guy. There it is. It's running. It's ready. And if I want to terminate it and make it stop, I can do this. I can send terminate to it. Now see, if I wait long enough, nothing happens. So you have full control of the processes in Smalltalk, and this makes Smalltalk an interesting thing. Even though the threads are green, they're not OS level, it does give you something else in return. Full control over the process model. You can control exactly how things will and won't run in your image. You can get things to operate exactly as you desire. So, that's about it for today. Until next time, have fun with whatever Smalltalk you're using.